lesson 1.5, piecewise functions. The learning targets for this particular lesson are that you can evaluate piecewise functions, that you can graph piecewise functions, like in our exploration, that you can state the domain and range of piecewise functions, as you should be able to do with any function that you've studied up to and through pre-calc. We begin with the first learning target, being able to evaluate piecewise functions. This example actually comes from lesson 1.1. And so the idea is that we have, as you saw in the exploration, a function that is composed of three other functions, or three pieces from other functions. So there's a linear function here, y equals negative 2x, a quadratic, y equals x squared, and an absolute value function, y equals the absolute value of x. So these three pieces, or these three individual functions, come together to form a graph, or come together to make a function for whatever. It could be a real-world problem, and in this case, it's probably just something that's made up. So when we're asked to find f of negative 3, we are inputting negative 3 for x. So instead of x, we have f of the opposite of 3. And so that means that we're inputting this for x. We should not do this for all functions, because not all functions are going to be graphed where x equals negative 3. This one right here, the bottom one, is only graphed for values where x is greater than or equal to 9. The middle one, the quadratic, is only graphed where x is less than 9 and greater than negative 2. The top one right here, where x is less than 2. So for f of 3, that's what I need to do. I need to do the opposite of 2 times negative 3, which is 6. So I use the top function because that's the interval of domain that I use, x is less than negative 2, for this number. Now, if I'm doing f of 10, well, then I have to look, the middle function has a domain between negative 2 up to 9. The last piece of the function has a domain for x is greater than 9. So when I go to do f of 10, I have to use the bottom piece, the absolute value of x. And I'm just going to put it in this because I don't feel like doing the formatting. So it'll be the absolute value of 10, which is 10. So there's our answer right there for f of negative 3 and f of 10. Let's take a look at letter B. Again, evaluating piecewise functions. And the same, for this function also, we're going to look at f of negative 3. First, I'm going to look at the three pieces. I have a constant function, y equals 6, which is a horizontal line. I have y equals 3x minus x squared, which is a quadratic, and again, the absolute value of x. For f of negative 3, this interval won't work because x has to be greater than 12 or equal to 12. Here, x has to be between 0 and 12, and here, x has to be less than 0. For f of the opposite of 3, I'm going to use this, the top equation, because it has the right domain and interval that I need. And so for f of the opposite of 3, the answer is just 6. Now, when I go to do f of 10, I need to look and see which function I should use. The last function is only for when x is greater than or equal to 12. The middle function, this quadratic piece right here, is when x is between 0 and 12. Since 10 is between 0 and 12, that's the function I should use right here to evaluate f of 10. So for f of 10, I have 3 times 10 minus 10 squared. So that's going to give us 30 minus 100, which is negative 70. So that's how we evaluate piecewise functions. Our next learning target is to be able to graph piecewise functions and state their domain and range. So I've taken these three pieces, the opposite of the quantity x plus 4 squared. Oh, I forgot the plus 2, so I better add that. Plus 2. The next one being 4, so that'll be y equals 4, horizontal line. And then the linear function 3x minus 15, I put those into my graphing calculator, and I'm going to make some tables so that I can graph these. And I'll put the tables right on my paper. So for the first one, it's where x is less than or equal to 4. So I'm going to make my first table right here, and I'll pick some values of x. And I want to get the true piece of the function, so I may even look at the graphing calculator and see what that graph looks like. I can see where the vertex is and how it moves to the right and to the left, but I also see where negative 4 is, but that's where the vertex is. So that's really important to know. And I'm supposed to include this value of negative 4 since this is less than or equal to 4. So when I make my tables for this, I put my negative 4 and I also put next to it a solid dot because of the equality. I want to make sure when I graph it that has a solid dot. And so I have negative 4, negative 5, negative 6, negative 7. I just need a few points to finish this parabola or to get the curve of this parabola. So I'm going to put in the opposite of 4, the opposite of 5, the opposite of 6, the opposite of 7. Once I actually have it in table form, opposite of 4, opposite of 5, opposite of 6, opposite of 7. And my numbers are 2, 1, negative 2, negative 7. 2, 1, negative 2, negative 7. Notice that it's less than or equal to 4. So this piece of the graph is going to continue on infinitely, just as this quadratic continues to the left infinitely. So when I go to graph this, I'm going to put a closed circle at negative 4, 2. Make sure I have a closed circle. Then I put a point at negative 5, 1, and negative 6, negative 2, and negative 7, negative 7. And I connect those, and I end with an arrow because the graph continues on infinitely as we go through this domain left, continuing going left of negative 4. Next, I'm going to look at the middle piece of this graph. The middle piece of this graph is just a function of 4, so that's super easy to graph, but that's between x is negative 4 and 2. So as I look at this, I know that it has to go from negative 4, and there's no equality, so that has to be the open circle. Because it's such a simple function, a constant function, I'm not going to worry about them in negative 4 and 0 and 2. And I can plug those in if I want. 2 also has an open circle. Now I don't need the calculator. I know the output for all of these is 4 no matter what value you plug in for x. But if you want, you can look at your graphing calculator, go to the second table, and look at y sub 2. You can put in opposite of 4, 0, 2, all numbers in between them, and they will always give you 4 in the y sub 2 column. So I go to graph this on my graph paper, and I start at negative 4, 4, and I put an open circle. I go to 0, 0, and that's a closed circle, and 0, 2, and put an open circle, because those are the ends, the starting and end points, but it doesn't have equality there. And then I connect them with a line. There's my constant function at y equals 4 for that piece. Lastly, we're going to look at this last function, this linear function, where x is greater than or equal to 2. And again, I want to look at the graph just to get an idea. There it is, greater than or equal to 2 will start below the x-axis and come up through, it looks like a y-intercept of 5, which we can solve in a minute. So we're going to make our table. Right now, because we're graphing, we can just worry about making a table. And we start at 2, 3, 4, 5, 6. It's going to continue on infinitely. I probably should have marked that back here too for the -7. -7 on the first function. We have equality at 2, so I'm going to put a closed circle. And then I can go to my calculator or by hand, or calculate however I want in my head. I'm going to plug in 2, 3, 4, 5, 6, and I'm going to look at y sub 3 for each of these numbers. -9, -6, -3, 0, 3. -9, -6, -3, 0, 3. And so I will now plot those. At 2, -9, I have a closed circle, so I'll color that in. At 3, -6, well, that didn't do very well. 3, -6, 4, -3, 5, 0, 6, 3, and it will continue on from there. And that was 2, -9. So I'm going to put an open circle and close it with coloring, and then connect these to make my line. It's not working out so well on the board. Keep following the slope and draw an arrow to continue the graph on infinitely. There I've graphed each of the 3 pieces, making sure to pay attention to whether the circles, whether those endpoints are open or closed, paying attention to the fact that this one goes infinitely in a negative direction, and this one goes infinitely in a positive direction, both in terms of x and y. This is not graphing well, I don't like this. Anyhow, now we're going to look at our domain and range. It will vary from function to function, but we want to look for several things. The first thing we want to look at is, are there any interruptions in the graph, or does it continue on? So it's kind of like a vertical line test. Is there always a point? Well, as I go to the left, there's always going to be points over here. I'm going to undo those because I don't want to see those. Actually, I'll just erase them. And that does work for all of this. The part that I have to be concerned and cautious about is where the graph, where the functions change. Obviously, the ends are easy. This one's going up infinitely, this one's going down infinitely, it's also going right infinitely and left infinitely. Let's focus on domain first, where we're looking from going from left to right. This piece right here, x is less than or equal to 4, we could write that. But when I join it with this piece at 4, there is a point. And then at -3, all the way through, there's no interruptions. Yes, it jumps vertically, but there's an x value for every one of these numbers. Going from left to right, even here, there's a closed circle down here. Now, if they were both open, then I would have an interruption in the domain. I would have to do 2 separate domains. But because I have this closed circle here, as I go from left to right, I have all the x values. So my domain is -infinity to +infinity. When we go to look at the range, we're looking at up and down. So the range for these numbers, this graph is going down infinitely. Then we have to be careful about where it starts. Yes, this one starts here, but this one goes down past that, so we don't have to worry about that, this point here, because this covers all of it. All the way up to here. Now I have to be careful. If these 2 pieces, this one and this one, were the only ones, my range would be from 2 to -infinity, and then just 4. And I'll show you what that looks like in a little bit, because we'll get to one like that. But with this, here's a point right here. So I'm kind of going horizontally across here. I have a point, I have a point. Here I have a point, and here. Over here I have points. It doesn't stop here. This function keeps going up. So for all y values, I have a point on the graph. And so this is also -infinity to +infinity, which is not always the case for piecewise functions, but in this case, it is. Let's take a look at one more example, and then we'll have some time in class. Hopefully from your exploration you saw some things about this as well. Pause this real quick while I load these into my calculator. Once again, I'm going to go through the same steps of making my table. Wow, this graph looks very complicated, but It's not too bad. I see the V from my first graph going on the left and going to the right, and that's the first function. I see the hyperbola, the curves in the lower quadrant 3 and in the upper quadrant 1. So I know that that is the second function, rational function, and then I see a square root function, which is this one that's going up. It's like half a parabola on its side. So we have these functions, we can get our table, but as we make our table, we need to pay attention to where it exists. This one is for x is strictly less than 0, so I know there's going to be an open circle at 0, and it's going to go to the left infinitely. So this arrow is going to go on infinitely to the left. I'm going to plug this into that function that's in my first table, because that's my first function, y sub 1. So I'm going to plug in second graph for my table, and that didn't work. I'm going to plug in 0, and -1, and -2, and -3. 0 actually has an error. That shouldn't be for this. Oh, no, it doesn't. I'm looking at y sub 1, sorry. So it's -4, -2, 0, -2, and I know that the pivoting point is at 0 because it's coming back on the V. So -4, -2, 0, -2. And I'm going to graph that. An open circle at 0, -4. 0, -4 is an open circle. -1, -2 is a point. -1, -2, 2, 0. Really, it's not going to keep my 0. And -3, -3, -2. So I have this V shape right here. There's the vertex of that. And I'm going to follow the slope and draw an arrow. It continues going to the left and down infinitely. My next piece is the rational function 2 over x. And so that goes from 0 and including 0 up to but not including 3. So as I make my table for that, I'm going to have 0, which will have a closed circle. 1, 2, 3. 3 will have an open circle. And I'll put those numbers into my table. So we have to have 0, 1, 2, 3. For our rational function, which I have in as y sub 2, we have an undefined value, 2, 1, and 0.6 repeated, which is 1/3. So I have an undefined value, 2, 1, and 1/3. For my undefined value, I just have a vertical asymptote is what I normally would sketch for that. And I can put that in for now, but I don't really need it in the graph because I have an open circle there anyhow. But so we have 0 undefined, and now we have 1, 2, and then 2, 1, and then 3, 1/3. So what's happening is we have this piece of the hyperbola right there, except I made a mistake and continued drawing it to the right, and it ends at 3, 1/3, and it should have an open circle there. So at 3, 1/3, I should have an open circle, and then continue on up this way. And my technology is not cooperating, but you get the idea. Now we move on to the last function. Let's make sure we have an open circle there. I really need that open circle when I go to our domain and range. It's somewhere in there. It's supposed to be at 1/3. Let's see if I draw a smiley face if it'll work. There we go. Alright, so now our last function. We have the square root, which starts at 3 and continues infinitely in a positive direction. So that's the third function. So we have to go back here. We have to do 3, 4, 5, 6. At least get some numbers, not 45. 5, 6, and we can add more if we need to complete the table. Now on this table, we're going to go to the third function. And remember that for this one, it's a closed circle at 3, 2. So we have 3, 4, 5, 6. We have a closed circle here, and it goes on infinitely. So my numbers are 2, 2.4, 2.73. 2, 2.4, 2.73. I am going to throw the number 10 on there just to see how much it goes up by so that I can complete my graph. That's 3.8. So not much. So now I can graph that. At 3, 2, I'm going to put a closed circle. And then at 4, 3, 2, 4, 2.4. So it's going like this. 2.7, yeah, I didn't do that very well. At 5, it's going to be, at 6, it's going to be 3. At 10, it's going to be 3.8. And it goes on. So there's my closed circle. Let's hope technology cooperates this time. Alright, so again, we're going to look at the domain and range. The domain for this is, again, as I go from left to right. So as I go from left to right, it goes infinitely to the left. I have to be careful here because there's an open circle, and then I look and see, are there any closed circles on this line? There are not. So the domain stops at and does not include 0. So we have from negative infinity to 0, not including 0. And then as I go to the, continue going to the right, it has values. That line, that curve, and even here. Even though there's an open circle here, there's a closed dot above it. So it keeps having it all the way and continues on infinitely. So that will give us that part at least. So this goes from, again, not including 0, on to infinity. My biggest caution is where they jump or where there's open circles. As long as there's a closed circle to fill it in, I'm okay. Now we're going to look at our range. So for our range, we start at going down infinitely. It's coming up. It looks like it stops here, but there's a point here, so I don't have to worry about that. All the way up until I get to the y-axis. There's a closed circle here. There's nothing above it until this point right here. And that was the 3 1/3. It's hard to see on my graph. So I have to start with negative infinity up to and including 0, because that point is on the y-axis, or the x-axis, it's on y equals 0. And then I have nothing until I get to this open circle at 1/3. So it starts back up, but not included at 1/3 because it's an open circle. And then as I keep going up, it keeps having values both here and here. So we're good there. We have y values for those. So this goes on infinitely at this point from the 1/3. And that concludes our video notes on this. If you have questions, please make a note of them. We will see some things tomorrow in class as we follow up on this lesson. Have a great day.